All right, so today we're moving up to the next layer of the network stack, to the network layer. So what is the service that's handled at the network layer? Okay, what's the main protocol? IP is the main protocol. What's the main service that IP provides? Addressing. Okay, that's a good answer. But what's important about addressing? That's basically
routing.
Routing. So the most important service provided at the network layer is routing. Routing is handled at the network layer. So, and as Abdullah mentioned, IP is probably the most famous network layer protocol.
Is it UDP for wireless or it's transport?
UDP and TCP, so I heard someone else say TCP. UDP and TCP are transport layer protocols, and we're actually going to talk about that next. But all IP does, so an IP header, there's a bunch of things in an IP header, but the most important thing are source and destination. And each of those is an IP address, and that will determine how downstream routers handle the packet, how downstream routers will send the packet on. So the most widely known feature of IP is the IP address. So every computer attached to an IP network is assigned an IP address. On the internet, the internet is an IP network, and every device attached to the internet must be assigned a unique IP address. So, for example, every computer on the internet has a unique IP address. Is it okay for a computer to have more than one IP address?
Yes.
Yes, it is. So the uniqueness only goes in one direction. So in other words, every device on the internet has to have a unique IP address, but it's okay for a device to have more than one. So for example, I'm sure you know what IP addresses look like, but for example, our server in the CSE department, red.cse.urview.ca, has IP address 130.63.96.21. So each element of the IP address is a byte. There's 255 possibilities at each stage. So it's interesting that they break it up like this. And what you should notice is that these addresses have a hierarchy. In other words, these dots, roughly speaking, this is not a completely accurate characterization of what's going on, but these dots might be thought of as breaking the address into subnets. So there's like the 130 subnet, 130.63 subnet, which is further restrictive. I think 130.63 is York.
Yeah.
I think that's the York subnet. 130.63.96, which I think is York.cse, cse.yorku. This is yorku.ca. This is cse.yorku.ca. And finally, the individual machine, which is this number. So in multi-hop routing, In multi-hop routing, devices maintain a list to ensure that packets are sent the right way. So, for instance, we've got a router. Let's call this a router. Packet comes in here, and packet can be sent in one of two directions. Basically, the router's job is for every incoming packet, figure out what's the right way to go. So, in multi-hop routing, routers maintain routing tables. To ensure data is passed along the correct route. And generally they work like this. So a packet will come in, the router will have a fixed relatively small number of links, and basically it will assign them, it'll pass something along here if the address fits a certain pattern, let's say 130.star, and it'll pass it along the other link if it's anything else. Or let's say there will be another link and that'll be 128.star or something, and it'll generally be a default. And in fact, if you've ever used a Unix computer, and you've looked at, I think the command is netstat. So if you look at the command netstat, that'll tell you the routing table that's currently being used by that device. General PCs that aren't routers, they'll have very simple routing tables. They'll basically be, the Ethernet that I'm connected to will be one entry, and everything else will be routed to a gateway. Okay, so this should all be reviewed to you. But roughly speaking, here's what internet routing looks like in a diagram. So this will be figure 1. So there'll be some source, some packet source, and some destination. The destination will have an IP address. Let's say it's red.csc, so that'll be 130.63.96.1. So the source will pass through some routing gateway to a high-level router. So there could be a lot going on between here and here, but there's a router, and this is through some gateway. This is the router for, let's say, the 130.star subnet. So this router can go in a couple of different directions. But let's say 130.63s are passed down here, and this would be 130.63.star subnet. And then this can go in a number of different directions. But up here, let's say this one is the 130.63.96.star subnet. And this is then directly connected to our destination. So we can see that routing, again, this is an approximation of reality. Generally, it's not true that routers work in exactly this way, where each dot neatly separates an IP address into subnets, but this is a way to think about it. And broadly speaking, routing on the internet is hierarchical like this. And the reason it's hierarchical is because not every device on the internet can possibly keep the entire routing table of the entire internet. So spreading it out into hierarchical domains is a way of decreasing the complexity of routing.